we are going to do the experiment on verification of Thevenin's theorem. So we will start by explaining what Thevenin's theorem is. So Thevenin theorem is that is in a circuit containing many voltage sources and resistor, we can replace it with a, that is in the case of a linear circuit, we can replace it with a single voltage source connected in series with a resistor across the load. So how will we find the Thevenin voltage theoretically? Theoretically, we will find the Thevenin voltage such that we will open circuit the terminals across the load and find the voltage across this open circuited load terminals. And how will we find the Thevenin resistance? We will find the Thevenin resistance across this load terminals such that the sources, that is the voltage source, is replaced by the short circuit and the current source is replaced by an open circuit, that is all sources are replaced by this by its equivalent internal resistance. So today what we will be doing is we will be verifying this Thevenin circuit. So here we will be finding the Thevenin circuit in such a way that we will find the voltage, that is the Thevenin voltage across the load terminals, and we will find the short circuit current which will pass through this load, that is we will short circuit the load terminals and find the short circuit current. Then we will find this open circuit voltage, that is the Thevenin voltage divided by the short circuit current, which will give you the Thevenin resistance. Okay, so we will start.
Okay, so we will be starting with the verification of the Thevenin voltage. We will wire up according to the circuit diagram you can see over here. We will be finding the open circuit voltage, that is the open circuit voltage across the load terminals. So that will be the Thevenin voltage and it will be indicated by this voltmeter. You can see that the supply over here is DC supply. So we will be using moving coil instruments here, and all the resistance shown in here are the rheostats which will be connected in fixed mode. So we can wire up the circuit. So we will start from the supply. So this is the 30 volt DC supply. From that we are having the 200 ohm 1.7 ampere rheostat. So we can see that it is connected in fixed mode, that is the two terminals over here are connected. We are not connecting the variable terminal onto here. So we are having these two points used. From that we are connecting onto the 100 ohm rheostat, 100 ohm 3 ampere rheostat, which is again connected onto this 100 ohm 3 ampere. Okay, now we have to find the Thevenin voltage across these terminals. So we are connecting a voltmeter across these terminals. So you can see that this is a DC voltmeter. A straight line over here indicates that this is a moving coil instrument. So we will find the open circuit voltage. Now we will give the supply and find the open circuit voltage. Supply. I will switch on the supply. Okay, now we can see that this voltmeter reading over here is 11. Okay, now we will verify this with the theoretical value. Okay, so you can find the theoretical value using this circuit. This is the same circuit, that is it is the open circuit voltage, right? So as the open circuit voltage is being found, this resistance is not taken into account. So the open circuit voltage will be 30 into 100 by 100 plus 200. So you can see that the Thevenin voltage which we obtained theoretically is 10 volt. Okay, and what we obtain experimentally is 11 volt. That may be due to the resistance in connecting wires and any small errors in the lab, in the rheostat, all those things may have added on to that. Okay, now switch off the supply and connect the ammeter such that we can find the short circuit current through this terminals. Okay, now we will find this current by switching on the circuit again, and you can get the short circuit current. Here also we are using a DC instrument, as the supply is DC, and you can find it by the indication of a straight line over here. So you can find that the current is 65 milliampere. Okay, so we are getting the current of the short circuit current of value 65 milliampere. Now we will compare both the theoretical value. Okay, now we will compare the theoretical value with that of the practical values which we obtained. So you can see that the Thevenin resistance which is found across the terminals. Okay, so we will replace this 30 volt by a short circuit, and you can find that 200 ohm is parallel with 100 ohm, which is connected in series with the 100 ohm, and we can find that the theoretical value of RTH which we get is 166.67. Okay, now we will compare the theoretical value with that of the practical value. So this is the Thevenin voltage which we obtained practically, that is 11 volt, and this is the Thevenin the current, that is a short circuit current which we obtained practically. So the Thevenin resistance is the open circuit voltage, that is a Thevenin voltage, divided by the short circuit current. So we can find that the Thevenin resistance which we obtained during the experiment is 169.2, and the Thevenin resistance which we obtained theoretically is 166.67. So these are almost close to each other. Now we will connect the load onto this experiment and find different values of current and verify this. Okay, now we will be wiring up the circuit to find the load current through the load, and we will be varying the load position to different values of 100, 300 and 500 ohm values, and then we will find the load current using an ammeter which will be connected in the circuit to find the load current. So we will now show how to position the rheostat at different values of 100 ohm, 300 ohm and 500 ohm using multimeter. Okay, so we are having multimeter probes over here, and this is the multimeter which we are using. So this will show the value of the ohm for different positions of rheostat. So here we are having the fixed terminal, and this is the variable terminal. Okay, so now we have disconnected this rheostat from our circuit, because while we are connecting this onto the circuit, it is giving the Thevenin resistance across this resistive source. So we have to disconnect it from the circuit and find the position at which we are getting the different ohm position. So here we will first go for 100 ohm position. So I have put the positive probe, that is over here, and now the other I will be connecting in the variable part. Okay, so here you can see that the multimeter is reading a value of 0.100 kilo ohm, which means it is having a value of, showing a value of 100 ohm. Similarly, we can move this variable terminal at different position, and we can get the value of 200, 300 and 500 ohm. Okay, so we have found RTH by finding the open circuit voltage and short circuit current, and finding V open circuit, that is the open circuit voltage divided by short circuit current. That way we have found, and also we have found RTH theoretically. Now here what we are going to do is, we will short circuit, that is the supply terminals, we will short circuit the supply terminals, and over here we will use multimeter to find the Thevenin resistance. So this is another method where we will be short circuiting, that is the concept of the theoretical finding RTH, that is we will be short circuiting the voltage source and we will be finding the Thevenin resistance across this load terminals. Okay, so from the circuit you can see that 200 ohm and 100 ohm resistance will be connected in parallel while we are shorting this DC supply. So that can be seen from the circuit, that is, this is our 200 ohm and this is our 100 ohm. They are connected in parallel and also they are in fixed mode. As I have previously told, we are connecting this in fixed mode, and we are having a 100 ohm resistor and we have to find this resistance across this terminals. Okay, so this is that 100 ohm resistance and we have to find the resistance across these terminals. Okay, so as I have previously told, this is the positive terminal, that is this red. Okay, this red is the positive terminal and this black is the negative terminal, and this will be connected to the respective part of the supply. Okay, so supply, that is, this will be connected to the positive part and this will be connected to the negative part of the supply. Now what we have to do is that you have to switch on this multimeter, and here you can see that there is an adjustment for ohm, right? So while you click on ohm, you can change the range also, because okay, for a lower value of ohm it is not indicating, so I am going for kilo ohm range. Okay, so you can directly see the resistance, that is the Thevenin resistance, which can be read from the multimeter, and it is indicated as 0.17782 kilo ohm, that is equal to 177.82 ohms. Okay, now we will be connecting with the load for the same circuit. So here you can see this is the 30 volt DC supply. You have the positive terminal over here and the negative terminal over here. Positive terminal is represented by a red knob and the negative terminal represented by a black knob. From there we are connecting the wires to the resistor. As previously mentioned, this is the 200 ohm 1.7 1.7 ampere rheostat. This is connected in fixed mode. We can use rheostat both in fixed mode and variable mode. So here we have connected in fixed mode, that is this two knobs. Here we have given the connection so that we are getting this entire resistance across this. So first I have connected the 200 ohm resistor. Then from that we can see, as in the circuit, this 100 ohm is connected in parallel. So this is the 100 ohm. And then we are having again a 100 ohm. And this is also acting as a fixed rheostat. So we are having the connections in this two knobs. Now we are having the load. And you can see this is the ammeter to measure the current through the load. And we know that the ammeter is always connected in series to measure the current through that portion. So you can see that this ammeter is connected in series with the load so that we can measure the current which passes through this load. Okay, so here also you can see the positive and negative terminal. So this part is connected to the part which comes from the source in the positive part. And this negative terminal is connected to the negative part of the supply. Okay, and then we are having this is the ammeter. Okay, and you know that this is the equipment, right? This is the instrument to measure the current. So this is never kept vertical. We will always keep this instrument horizontal. Okay, now the instrument has to be kept horizontally by measuring the readings. Now we will switch on the supply and show you one set of readings, that is for the 100 ohm part. That is, this variable resistor, as we have previously shown, is now set at the 100 ohm value, and we will show the reading for 100 ohm value. So first what we have to do is that we have to switch on the supply, and the rheostat was in the minimum position, and from there we have varied it down to the 100 ohm part, and you can find the current. The current is 45 milliampere. Okay, so as you can see, the current is 45 milliampere. So now we can verify this with that of the. So we have obtained 4 practical values of resistance of 200 ohm, 300 ohm and 500 ohm. Now we can do the same and theoretically, that is theoretically you have found the Thevenin voltage and Thevenin resistance. Now you can connect the load resistance, that is for different load resistance you can find the load current using VTH divided by RL plus RTH. So we can verify Thevenin's theorem both practically and theoretically.